Hello, future engineers. This lecture series is 30A. This is about plane trusses under statics subject. I'll present here two examples, 3 and 4, where in example 3, it is about analysis of a truss, plane truss, using purely the method of joints. And in example 4, analysis of truss using purely method of sections. So I'll present the concept as I solve these two examples. So if you're still new to my YouTube channel, don't forget to subscribe and press the notification bell so that you will be updated of my future videos. And I hope that I will be an instrument of your success in your studies as civil engineering students, or even non-civil engineering students who have a subject on statics. So that's it, and I hope that you will enjoy watching. For the first example, problem 3, by purely method of joints, determine all member forces, then indicate if the member is in tension or compression. Of course, we always assume that the member is in tension, and if the result is negative, then it means that the member is a compression member. If positive, it is a tension member. So this is the given figure. So take note that we simply apply method of joints. So we first solve for the angle between, or this angle here. We draw horizontal line through C because we plan to isolate joint C first. So by symmetry, the angle is denoted by theta. Same is true with the member CD with the horizontal. It's also theta. So from the figure, tangent theta is 1.5 over 7.5. So therefore, theta is 11.31 degrees. So at joint C, first we sum up forces horizontal, then to relate FDC with FCD. So let's consider leftward as positive. So both are leftward. So FDC cosine of theta plus FCD cosine of theta equals 0. Therefore, we can cancel cosine theta and write FDC equals negative of FCD. Then next is we sum up forces y equals 0. FBC sine of theta, sine of 11.31 degrees, then minus 20 minus FCD sine of 11.31 degrees equals 0. So substituting the value of FBC in terms of FCD, which is negative FCD, then from here, from this equation, only FCD is the remaining unknown. So we can now compute FCD using your calculator. So F sub CD is equal to negative 50.99 kilonewtons. So that means FCD is a compression member. So 50.99 kilonewtons compression. Then FBC is the negative of negative 50.99. So FBC is 50.99 kilonewtons tension. Then we proceed to joint B. Then we rotate the axis. So, and downward, let's consider downward as positive. Summation forces y prime equals 0. So this is our y prime axis. And we consider positive in along y prime in the opposite direction as positive. So the component of FBD is FBD cosine of theta. Then plus 40 cosine theta equals 0. FAB and FBC are not involved because they are perpendicular to the y prime axis. So we cancel cosine theta, and therefore FBD is negative 40 kilonewtons, or FBD is 40 kilonewtons compression. Likewise, we sum up forces along X equals 0. So summation forces X equals 0. So FBC cosine theta minus FAB cosine theta equals 0. Again, we can cancel out cosine theta and write FAB equals FBC. Since we already found FBC, so FAB is also 50.99 kilonewtons tension. So next, we cannot proceed at joint A because there are 1, 2, and the reactions at A not yet known. So we consider the entire system. We sum up moment about A equals 0. There's only one horizontal reaction at E. And these are the reaction forces. So AY, of course, is obviously equal to 60 because we have two downward loads. 40 plus 20 is 60 downward. So therefore, AY is 60 kilonewtons upward. So summation of moment about point A equals 0 or support A equals 0, considering counterclockwise positive. So RE times 6, then minus 40 times 7.5 minus 20 times 15 equals 0. So solving for R sub E is equal to 100 kilonewtons rightward. So summation forces X, AX is also equal to 100 kilonewtons but leftward. So 100 minus AX equals 0, so AX equals 100 kilonewtons leftward. So this is the free body diagram of joint E. So we already computed R sub E, which is rightward. Then this is FDE. The angle here is also theta, equal to that. So we sum up forces along X to solve for FDE. So we can solve for FDE. So at joint E, summation forces X equals 0. So we have 100 plus FDE cosine of 11.31 degrees equals 0. So FDE is equal to negative 101.98 kilonewtons. So FDE is 101.98 kilonewtons compression. Likewise, summation forces Y equals 0. So FAE plus negative 100.98 sine of 11.31 degrees equals 0. So FAE is equal to positive 20 kilonewtons. So it is tension. Then we proceed to joint A. But before that, let's solve for the angle that AD makes with the horizontal. So this is the free body diagram. We had AX leftward, upward 60 kilonewtons. Then FAE, we have just computed 20 kilonewtons tension. Then FAD, and this is FAB, which is 50.99 tension. And the angle that FAB makes with the horizontal is theta or 11.31 degrees. So we just find theta AD, which is tangent of theta AD is equal to 4.5 divided by 7.5. So theta AD is equal to 30.964 degrees. So first, let's have summation forces maybe along X or along Y. Anyway, the remaining unknown is AD. So at joint A, summation forces X equals 0. So we have FAB, which is 50.99 cosine of 11.31 plus FAD times cosine of 30.964, then minus AX minus 100 equals 0. Solving for FAD, FAD is equal to 58.31 kilonewtons. Since it is positive, it is tension. So we have already found all the member forces. Then we check joint A by summation forces Y if it is really 0. So summation forces Y equals something. If it is 0, then it balances, and that verifies our answers to be all correct. So summation forces Y equals 60 minus 20 minus 50.99 sine of 11.31 minus 58.31 sine of theta AD, which is 30.964 6/4, then the result is almost 0. So that means our calculations are correct. And if you want to check further, I want to leave this to you. You have to check joint D. We haven't yet isolated joint D. You perform checking summation versus X if it is 0 and summation versus Y if it is 0. So that is expected to be 0, summation versus X at D, and summation versus Y at D expected 0. So I leave that to you as your exercise. Okay, so let's proceed to the next problem. The second example, which is problem 4 in my series. So by purely method of sections, applying the method of sections, determine member forces of AE, BC, BF, BE, CF, and DF. Indicate if the member is in tension or compression. So same sign convention, we always assume the member as tension, then if it is negative, it is automatic compression. So first, let's consider the section through AE because it is the first member to be determined. Then through these 4 members here, AE, BE, BF, and BC. And let's consider the left portion of AE, all forces to the left of this section 1-1, and we indicate the forces as tension of all members that are cut through this cutting section. And since all the 3 meet at D, then we sum up moment about B equals 0. Because the horizontal distance is 4.5, the vertical is also 4.5, the angle that AE makes with the horizontal is 45 degrees. And therefore, if this is 45 and that angle is also 45, AE is perpendicular to AB. And the angle here is 90 degrees. So summation moment B equals 0. And take note that this distance is 4.5 square root of 2, the moment arm of FAE, because that angle is 90 degrees. So considering counterclockwise as positive, so we have FAE times 4.5 square root of 2 plus 40 times 4.5 plus 20 times 4.5 equals 0. So FAE is negative 42.43 kilonewtons. So that means FAE is 42.43 kilonewtons compression. Then we consider we cannot solve one of the unknowns here from these 3 anymore. So let's consider section 2-2 and consider all forces up and right of this section 2-2. So let's indicate first the forces that are cut. So FBC, FCF, and FDF. So since FCF and FDF, the other 2 unknowns meet at F, so we can solve FBC if we sum up moment about F considering counterclockwise positive. So summation moment at F equals 0. So FBC times 9, then minus 20 times 4.5 equals 0. So we solve FBC as equal to 10 kilonewtons. So it is positive tension. Now we go back to all forces up and left side of section 1-1. Because we have found FBC, we can sum up forces horizontal equals 0. So left of section 1-1 again, summation forces X equals 0 to solve for FBF. So the X component of FBF is FBF, its magnitude times 6, horizontal distance 6, divided by the distance, which is square root of 6 square plus 9 square. So 40 rightward plus 30 rightward plus FAE, which is negative 42.43 cosine of 45 plus FBC, which is 10, plus FBF times 6 over square root of 6 square plus 9 square equals 0. So we can solve FBF. FBF is equal to negative 90.13 kilonewtons, or FBF is 90.13 kilonewtons compression. Then, uh, summation forces Y equals 0. This time downward as positive because all the forces are downward. So we have 20 plus 60 plus FBE, or FBE plus Y component of FAE is negative 42.43 sine 45, then plus 20 plus 60, then plus FBF, which is negative 90.13 times 9 over square root of 6 square over 9 square, 6 square plus 9 square, then equals 0. Then we can now solve FBE. So solving for FBE, FBE is 25.00 kilonewtons, or 25 kilonewtons positive, so it's tension member. So we have found all these four members. Then let's go back to the right section of 2.2, considering all forces to the right of section 2.2 and above it. So first, we can have summation forces horizontal equals 0, then summation forces vertical equals 0. So summation forces horizontal 0, leftward positive. So FBC, which is 10, positive, plus FDF cosine of 45 equals 0. So FDF cosine 45 plus 10 equals 0. So FDF is negative 14.14 kilonewtons, or FDF is 14.14 kilonewtons compression. Finally, summation forces vertical equals 0 and downward as positive. Then we have FCF plus 60 plus 20 plus negative 14.14 sine of 45. So FCF plus 60 plus 20 plus FDF, which is negative 14.14 times sine of 45, then equals 0. So FCF is equal to negative 70 kilonewtons, or FCF is 70 kilonewtons compression. So we already found all the members. So to check, let's consider section 3.3 and above, all forces above it. So take note that FBC is not cut. Anyway, if we include FBC, we have rightward and leftward, that cancel out. So that means we do not involve FBC. So checking summation forces about or along x-axis, if it is 0. So we have summation forces x is 40 plus 30, then plus FEE, negative 42.43 cosine 45, then plus FBF. FBF is cut, so it is included. FBF is negative 90.13 times 6 over square root of 6 square plus 9 square, then minus FDF, which is negative 14.14 cosine of 45, then compute. So the result is almost 0, so that means our calculations were correct. Then summation forces Y, to completely say that all our answers are correct. So summation forces Y downward positive, beginning with FEE. So its magnitude is negative 42.43, then times sine of 45 plus 20 plus 60, then plus FBE, plus 20 plus 60 plus 60 plus 20 plus FBE, which is 25. Then Y component of FBF is negative 90.13, so plus negative 90.13 times 9 over square root of 6 square plus 9 square, plus FCF, and FCF is negative 70, then plus the Y component of FDF, which is negative 14.14 sine of 45. Then computing, That's also almost 0. So that means all our answers are definitely correct. So that's all, and I hope that you will see my future videos about trusses. Then there I will discuss more challenging truss problems.